The op-amp, or operational amplifier, can be thought of as a voltage-controlled voltage source. It uses the voltage elsewhere in the circuit to control a voltage source that basically amplifies that voltage. An op-amp is usually modeled as a triangle. There are two inputs, and inside there is a wire between them. In the ideal world of an op-amp, these 2 points are maintained to be at exactly the same voltage, which makes sense because there's no resistor between them. Additionally, however, the operational amplifier attempts to ensure that no current whatsoever goes through this wire either. Typically, it does so by having an extremely high resistor right here. Because the resistor is so high, current is very unlikely to go through it, and if very little current goes through the resistor, then there must be a very small voltage drop through the resistor. A voltage drop which is basically zero. However, in order for the op-amp to help maintain this voltage, it needs to create its own voltage, which depends on the voltage that it's trying to maintain. It creates this voltage with respect to a common ground in the circuit. Incidentally, that ground is also the reference for knowing the quote-unquote voltage at this point or along this wire. That quote-unquote absolute voltage is really a voltage with respect to the ground, and it is, in part, what is amplified by the operational amplifier. In circuits, an op-amp will be modeled as a triangle with a positive and a negative input and an output, as you can observe here. The voltage at this point is the same as the voltage at this point, and the current in either of these branches is zero. These are what I call the fundamental assumptions of op-amps. The current in the branches connecting directly to the negative and the positive terminals of an op-amp are zero, and the voltage in the wires connecting directly to the negative and the positive terminals of the op-amps are the same. For example, suppose we had the following circuit involving an op-amp. Just focus on this left side for now. To effectively work with op-amps, we need to consider the implications of the two fundamental assumptions of op-amps. First of all, the current assumption. There is no current traveling through these branches, which means this battery is not going to produce any current. The battery is still producing 12 volts though, so at this point there will be 12 volts. According to the voltage assumption, that means this point will also have 12 volts. When analyzing circuits using op-amps, we start by considering the current and the voltage assumptions of op-amps, and then we start using laws like Kirchhoff's current law and Ohm's law to start analyzing different points of the circuit one by one. This is a scaffolding process where we develop information little by little and fill it in. For example, because we know that there is 12 volts of difference between this point and the ground, we can determine the current across this resistor. Let's suppose we determine that current and call it I1. Now the question is, what is the current across R2? Take a little bit to think about that. If you need a hint, remember that there is no current in this branch whatsoever due to the fundamental current assumption of op-amps. Have you done your thinking? The current in R2 is exactly the same as the current in R1 because there's no current in this branch, so all of the current that's exiting this node R1 has to enter through R2 into the node. So we determined what I1 was because we knew the 12-volt battery and the resistance. And now because we know I1, which is also across R2, we can determine the voltage across R2. Remember the sign convention. Observe that this voltage would be higher than 12 volts. Because the current that we now know goes through R2 produces a drop in the left direction, which means there must be a rise in the right direction. So we have seen that this op-amp is actually producing a voltage that is larger than the voltage initially fed to it. The voltage has been amplified. In future videos, we will see exactly how much. But the point is that the op-amp is increasing the voltage fed to it in order to get some specified level of amplification and create a higher voltage later on in the circuit that corresponds in a certain way to the voltage before. So remember the two fundamental assumptions of op amps. Number one, the voltage in the two branches connecting to these inputs is the same, and the current in the two branches connecting to these inputs is 0.